Okay, this is section 8.3 in your textbook on page 412. So we're finding angles using the cosine law. So at the very end of the last lesson, 8.2, I talked about when to use the cosine law. I mentioned to use it side, side, side. All this lesson is about how to use side, side, side and solving for the angle. Okay, so there's just a couple quick examples. So again, this is a triangle where the knowns are side, side, side. Okay, so right away, if you see a triangle, it's not a right angle triangle, and you don't see any angles known, all you see is three sides known, you know you have to use the cosine law. Okay, the other scenario, of course, is a triangle where you know the side, an angle, and a side where the angle is kind of between the two sides that are known. Okay, so these two scenarios you need to use cosine law. All right, so if we go ahead and plug into cosine law, here is cosine law. Again, I chose B, but it doesn't matter in this case. When you have side, 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 it absolutely doesn't matter. The only reason I chose B, or the only reason you would choose angle B, is if the question asked you to solve for a particular angle. If it said solve for this angle, this angle, this angle, you would set it up for that particular angle. Obviously, if you're solving for angle B, you'd want angle B in your formula. Okay? In this particular question, this is on page 413, it says 3 towns are connected by 2 roads as shown. A third road is planned that will directly connect Brookside and Hillcliff. So here's Brookside and here's Hillcliff, which are 16.5 kilometers apart. Find the angle to the nearest tenth of a degree between the new road and the existing road from A, Rolling Meadows to Brookside. So Rolling Meadows to Brookside, so they're telling us to find this angle. This is our new road. Okay, so that's the reason why we chose B in this case, because we're asked to solve for angle B. And this is an angle, of course. Okay, so if I plug in all those values, I rearrange these positives, I'm going to bring over and subtract. So 225, this is 100 plus 272 is 372. 225 minus 372 is minus 147. And then I need to divide by negative 330 to isolate for cos B. Okay, so these negatives cancel, and I'm taking the inverse cos of 147.25 over 330. Okay, I left the angle on the right-hand side. That's fine. Okay, if you want to move everything to the left away from it, and then just equate it at the end, that of course is the same as saying this. Okay, so we have our angle. Another way to do it is if you're good with formulas and you want to memorize a formula, you can rearrange the cosine law to solve for an angle directly. Okay, and the way we do that is, again, just working with the initial variables, move everything to the left side, so minus h, minus r, and then dividing by negative 2h, you're done. I've personally never bothered memorizing this because I just start with the original, and you can see it's like 2 steps away or 1 step away. Okay, but if you feel like memorizing the formula, you can go directly to this to solve for the angle. Okay, and again, just plugging in those values, you take the cos inverse of that result, and you'll get your angle. Okay, so same thing. Example number 2. It says runners in a 10K race follow a triangular course. The 3 legs of the race in order are 3.8, 2.4, and 3.8. So we head off from A. This is run 1. We go from C to B, run 2, and run 3, 3.8. Find the angle between the legs in each pair to the nearest degree. So they're asking for all of these angles, for this, and this. Okay? Whenever you're using cosine law to solve for a triangle, please don't use it more than once. Use it once and then use the sine law. Okay? Why would I say that? Yeah, sine law is a lot faster. It's a lot easier. Okay? In this case, for the first angle we look to solve, I don't have a choice. Okay? The reason I don't have a choice is because I don't have any angles at all. So I know this triangle in particular is side, side, side. I have to use this formula for the angle. So I end up with B is equal to 72. Once I have B is 72, which is here, and again, I just chose B randomly. It's the first question asked for angle B, but you could have chose any side to start. Then I use the sine law, so sine C over C. I use the sine law in this format because I'm looking for an angle, so I leave the angles on the numerator. Okay? And then I solve for angle C much quicker. I find out that C is actually the same angle. So C is here, this is 72. So if you know anything about triangles, we know these two sides are going to be the same, right? Because it's an isosceles triangle. But just to confirm that, I'm going to check the third angle, 180 minus my 272 angles, and I get this angle as 36. Okay? I'm sorry, I didn't need to confirm it. It was given in the question, right? 3.8 and 3.8. Yeah, so we actually knew, just by solving for one angle, we knew the other. So finally, our key concepts. If we have a triangle like this, again, note the nomenclature. Small a across from big A. How many times have I stressed that now? Right? That becomes, you can see, I hope it's evident how important that is now when we're dealing with these formulas, that you understand where the angles are in relation to the sides, or where the sides are in relation to the angles. Okay? So finally, here's my formula, my cosine formula. Again, this can be written for A, B, or C. Just switch the other corresponding letters. Here it is again rearranged for the angle. And then you can use the sine law to solve for the rest of the triangle once you have an angle with opposite side. Okay? And again, though, just to know, you do need 3 pieces of information to solve any triangle. And you can't just have a triangle like this, just to throw this in here. If you know this is, say, 53 degrees, and this is 10.8, you can't solve this unless we know at least one other piece of information, so it's always 3. So you can't use sine law on this, because you could have one ratio, but you would have 2 unknowns on the other side. So you won't see any questions like that, though. You'll always have 3 pieces of information. Any questions? All right, that's the end of 8.3.